Maybe Bob, do you want to give us a quick introduction into your journey and how you ended up building Weaviate? Maybe not like the whole journey, because that would be the 30 minutes full, but like the quick cut on how you ended up here today.
Yeah, sure. So first of all, thanks for having me. So I've been working with in deep learning and then specifically embeddings or in language for this is I think my 11th or my 12th year now. And I remember I saw them for the first time, and that was very magical. Um, and that was back then. That was like single word embeddings, and that took quite some time for me to grow in this concept of like, hey, can we do something for paragraphs of text and those kind of things? And that worked okay-ish. Important to bear in mind, this was all before transformers and LLMs and that kind of stuff. And out of that, the idea was born like, hey, we can actually, if we store this stuff and if we represent it based on these embeddings, then there are different ways to retrieve them and find them. So that was how that idea was born. And that is in 2018, I think, or something. And then we started to build. And that then I met my co-founder, who's also German, Etienne. He's not in Berlin, though. And he's now the CTO. And then we thought like, hey, there might be room in the market to build a database specifically for this stuff. But it's very important to bear in mind that the language like AI, etc., we didn't use that yet. It was still deep learning, machine learning, that kind of stuff. But that was how it was born. And then the Transformers got released, and then everything that came after that. But it's very important for people to know. It's like 10 years ago, this was like a tiny niche. This is like very small. So what it grew into now is kind of special, but it's nice.
What were the use cases for what you were building when you started? Like it was not RAG, right? Because there was nothing with like LLMs and retrieval and this kind of stuff. So what were the, because I mean, you started it, I think, as an open source project, right? But then at some point you built a company around it. So you had something in mind to like which use cases you would sell this into, right?
Oh, no, not at all.
Not at all.
So, no. So it's important to know. So a use case is always a trailing indicator of something. So if you see a certain technological innovation, people see an opportunity. It's always very abstract. So hey, there's something here, but to really articulate it in the form of use case is hard because people are not doing it yet. It's not a state of mind. So no, we didn't have that, right? So, but you saw this opportunity. Hey, we can. It's interesting that we could store. I remember the first thing that I ever stored. I still use it as an example. Was simply the text. The Eiffel Tower is in Paris, and the Big Bang is in London. And then you had to query landmarks in France, and then it showed the Eiffel Tower in Paris first. So which made a lot of sense, right? Because of the centroids of the, but there's something in here. But that was by no means explained in the form of things like RAG or those types of use cases. And I think there were a lot of new innovations. That's always the thing, right? So it's like so for example, if you look at the language models, the early language models were based on a philosophical concept where people were saying like, we believe we can say something about the meaning of words based on the distance that they have in a sentence. That sounds, I see some people like, oh, what? But it's actually very simple, right? So if you take the word Eiffel, then chances that you find the word tower after the word Eiffel are greater than if you find the word, I don't know, monkey after the word Eiffel. And how do you do that? You just count words, like literally. It's a great insight, right? So that was that research, how that was born. And everything came out of that concept, but this goes back all to the 60s or something. So it's the same with these types of infrastructure technologies. Then you go like, oh, hey, maybe we can do something with it, or something starts to emerge. But so you throw it in the world, and then you go like, oh, what are people building? And then that clusters around certain use cases, and then you can articulate the use case. But that use case is always a trailing indicator of something, never a leading indicator.
So which means that like as you described this like infrastructure layer, it's working very opposite to like application layer, because there, like you would say, I mean, a solution looking for a problem is very bad, right? But this sounds a little bit like you started with like, oh, I think this could be cool, but I don't know if anyone like needs it.
Yeah, so now I'm gonna do again what I did on the podcast today, but
Yeah,
I'm gonna.
because we have to disclaim we recorded an hour of chat already today before, so but on different
And
topics.
he was sweating and stuff, so it's like I gave him a hard time. No, so but the no, just a little bit. So, no, but
Yeah,
the
yeah.
no, but the a solution looking for a problem. Most of large big innovations have been solutions looking for a problem, right? I mean, can you imagine that you would go to Tim Berners-Lee, who was working on like the web, and go like, how are you gonna make money at this, right? Yeah, I don't know, right? But it's a nice way to communicate, stuff going back and forth. Um, Same thing. We should not forget that in the early days of like Amazon, Airbnb, etc., that the consensus was that people would never leave their credit card details on a website. That's not going to happen. Well, that was wrong, right? So I think it's perfectly fine to dabble around in an idea or in a concept where you're not sure yet what the application is going to be. You can't do that forever for a variety of reasons. But if you shoehorn it too quickly into something, then you probably lose a lot of opportunity in what you could have been building, right? So it's like it's perfectly fine to, if you're, especially if you can build something, right? There's nothing cooler than being able to build something. So you try something out and it works. And I mean, everybody who writes software in this room, right? So you know that feeling that you have like 900 GitHub repos, of which 2 are actually meaningful, which is like fine because you try stuff out, right? And that's how you learn, and you have a lot of serendipity, so you find stuff. So in the early days, it's perfectly fine to have a solution, but you're not sure yet what the problem is, and then you move into that direction.
So, what is Weaviate nowadays? And like, I mean, you now found some use cases, right? So, what are they?
Yes, now we did. Yes.
Yes. So what are those? And what is Weaviate now? Like, how does it evolve?
Yeah. So what happened for us was that, so one of the challenges that we had was that it was very hard for us to articulate use cases better than, oh, it's better search. And that is problematic for 2 reasons. Reason number 1 is like, if you're ambitious, like we are, or I am, I guess, is like search is not a big part of, is not a big, the market share of search is not that big. So you probably want to not do too much around pure search.
You say like the search market is not big.
No.
Okay. Like the whole, like also consumers. Are you talking about like B2B search? Or
Yeah.
like,
So it's
okay.
like so I mean, um, uh, Elastic makes money of logging, right? That's their
Okay.
big
If you
business.
like exclude all the revenue Google is doing of search,
Ah,
which is like,
okay, fair enough. That's fair enough. But sorry, that you make a good point. I meant that's consumer search. I mean, what they call enterprise search or B2B search. There's actually, you want to know the reason for that? There's actually an interesting reason for that. So it's like, if you work in infrastructure, you somehow need to have use cases that accumulate data. And the problem with search is that, let's say they have e-commerce search, but you have like really, really, really good e-commerce search, and you have you power a web shop that has 10,000 products. It's a really good search, 10,000 products. Good, great. How much are you going to pay for that? Just not a lot, right? And so you run at some point out of these use cases. But if you have a use case where you store more data, that the value comes of storing more data, then people are willing to pay you more. Just think about it, that the companies that you work at, the infrastructure you're spending money on, it's the ones that accumulate a lot of data is what you pay more and more for. So that's why logging companies make so much money, right? So it's like, that's because you need to keep throwing more data in. So so that was a problem. And then the second problem was was in the word better. because, yeah, you can do something better, but then, then the ones who were doing it probably will catch up or something. So there was a problem, right? It was like a challenge of like, And then we were helped by the market with the release of ChatGPT, because the question that immediately came out of that was like, how are we going to do that with our own data? And then it was that was like, hey, we can do that, because the nice thing is with these things like these the queries that you have from the perspective of an LLM, they just do better with they're just more semantic search kind of question, right? So if somebody asks, like, to stick with my previous example, you don't use keywords to search, but you say, what should I do when I'm on my holiday in France, right? And then you want to find that Paris example. So it was just a nice fit. And then, of course, we got that famous paper of retrieval augmented generation. And it all nicely came together. And that was where the first real use case emerged. And now you had a good story around that use case, because, hey, if you want to do this stuff with your own data, look, it's just a press of button, you throw data at it, and you're good to go. So that was that first real good use case that came out of it. But we could have never predicted that, right? That took time to get there.
Why do I need a dedicated vector database to do retrieval augmented generation?
So the two reasons for that. So the first one, I hope I just answered, right? So it's like if you deal with the embeddings, the way that people interact with the LLMs are more semantic in nature. So just think about, if you do Google search, you do it more keyword kinda, and whereas that if you talk to an LLM or you communicate with an LLM, it's more semantically. So it's kind of nice. So that's one.
Yeah, I mean, my question was not on like, but I think nowadays a lot of people use embeddings, but they use it, I guess, with like Postgres and PG Vector.
Yeah, I wanted to get there. So the second thing is that you have is the way that you build these types of applications, the way that you interact with the models, the way that you store the data, retrieve the data, is very specific for AI cases. So you can also plot this on history, right? So for example, when MongoDB came out, right? So a lot of people were saying, hey, you can store JSON in Postgres. Why would I do that? And the answer was not so much in how it was stored, but how you use it. So it was a very smart and powerful thing, in my opinion, what they did. But that they basically said, so if you, for example, think Python, so you create like an object or a dictionary in Python, and what you then could simply say, if you point it over there, it will store it somewhere safely for you, and you don't have to care about it anymore. It was very powerful. So there was more like an interaction thing. So going back to these to these AI applications, the way that you build these kind of things is just if you focus on the use case of the end user, which is, we call it AI native applications, then to get from A to B is just way shorter. If you go to our homepage and you scroll halfway through, I think, you see a hybrid search query in SQL and the exact same query in Python. And in SQL, it's, I don't know, 40, 50 lines of code. And in Weaviate, it's like 4 lines of code. Plus, that if you want to do that in Postgres, you need to compile it yourself, because you need different modules, right? To get there, that's harder. If you go to more production cases, it doesn't run, it runs sequentially. So that's a problem if you scale it up. So the point is, if you build infrastructure and you have a focus, then you make it easier for engineers to build and scale. And that's the answer to the question.
So, okay, and then, but this means, like, what's the future for Weaviate look like? Like, will you go full down, like, we're a database company, or will it be more like we're going to do the whole stack across, like, bringing use cases into production, also across other angles? Like, how does the future look like for you?
Yeah, so I don't know exactly, because there's still so much happening. But what I can tell you is so if you build companies like ours, then you have a couple of options on how you want to position yourself and what you want to do. And one of the decisions that we made was that we want to focus on helping developers be successful quickly. So that means we're not saying, for example, oh, we're the cheapest, or we're positioning ourselves of, oh, we're the fastest or something. That is something we just don't talk about that much. We talk about enablement. Like, this is how we help you to go from 0 to 100 in just 10 minutes time when you build AI native applications. So for example, right, that was when we started to release the embedding services, the agentic services, and all those kind of things around the core database to help people build. So we've decided our focus is going to be make it as easy as possible to go from 0 to 100 in the least amount of time. And also for everybody. So also people who want to build AI applications, who might be engineers, but might not have a PhD in this kind of stuff, right? So you want to help people to build. And so that direction will inform us to what kind of product features and God knows what will follow in the future. So you listen to the community open source, you listen to your customers, you learn from them, and that's how the platform, if you will, evolves.
In your time now, you like building Weaviate, what have you learned about commercializing open source software? Like what are the learnings there? Because I
How
see
much
it.
time do you have?
We have some time, yeah.
Okay, so what I believe is that if you build open source, then there's like a pre-revenue and a post-revenue situation in your company. If you yeah, then no, take it. That's fine. Oh, no, but in the pre-revenue stage, the only focus that you have is on adoption and learning from people, like what they're doing, right? So and this is very difficult because in the sense that a lot of people game the system, and I would highly recommend don't do that. um, uh, um, Really honestly try to understand, what do people build, what do they like, what don't they like, listen through the lines, right? So it's like it might be type of language that you're using, and I don't mean programming language, but in your documentation it can be anything, what they like, what they don't like. And then this thing, what we call community, starts to emerge, and adoption starts to emerge. So then at some point people are using it, right? So you see that usage and your product keeps growing. Then the moment that you start to decide to start to monetize, and then what to monetize, that's a whole other tech. I'm happy to talk about that too, but let's say that you know what you want to monetize. The moment that the first euro or dollar or whatever comes in, I believe that your open source, the role of open source changes drastically. Then open source changes into inside of where you can help people with your offered services. So for example, at Weaviate, we see on average 2.5 databases are being spun up per second all over the world. So that just, and that of course goes depending where it goes in the world, so all over the world, everywhere. All that information we try to enrich with who's using it, what are they doing with it, and so on and so forth. And that's why you build then a whole machinery around to see, like, how can we help people. So then the role of open source changes more, a little bit more to an insights engine, if you will, about usage. So that is how, in a nutshell, open source changes from day zero, where you just build something, all the way that you have that adoption, that is running, and that you try to build a company around it.
And do you want to explain us how I find what to monetize?
Yeah, sure. So if you build technology, at the highest level, the technology you're building can be divided into two groups. And that is of if the technology is stateful or stateless. So, for example, something that is stateless is a framework. Something that is stateless is an LLM, and so on and so forth. Things that do not keep state. Then you also have stateful stuff. So if you go like, what does he mean? Think about Excel. The power of Excel sits in the fact that if you type a bunch of formulas and you save it and you close it, and then you open the Excel file, that it shows you the exact same formulas that you put in yesterday. Because otherwise it's like not very valuable, right? That is the same for core infrastructure or software that you're building. In the case of us, what we do at Weaviate, we have stateful technology. That's what people pay us for, right? So they need to, we need to make sure for them that if their customers put their data in our database, that it's still there tomorrow. That's what they pay us for, because otherwise they could be using open source, right? Because we don't care. They can use open source, that's fine. But they want that guarantee, right? So that's what people pay you for. So if you build stateful technology, you start monetizing in almost all cases around the statefulness. So dear customer, or no, dear user, if you become my customer, you can sleep at night, right? So, we sometimes have that with our companies that we talk to, hey, we run this huge Weaviate cluster. Great, we can help you. No, we're fine, we're good. Oh, great. What are you going to do this weekend? Yeah, with the family. Oh, great. So what happens if the cluster goes down? Yeah, right. So that's what you sell, right? So that's the opportunity there. If you create stateless technology, it's harder. So then you need to come up with something to keep state, right? So think about a framework. So let's say that you, yeah, mm, think any framework, right? Any framework is stateless. So then the thing is, why would people pay you, right? Because they use the stateless framework. So you need to somehow add state to the framework. That's more difficult. But so those are the two things to think about. And then if you figured out what makes it stateful, then you need to make sure that people add a lot of data. And
Thanks.
you're
When,
very
when you when you look at like what people nowadays use Weaviate for, like where do you still see the biggest blockers in actually bring it into production?
So if you the way to look at the journey that every engineer goes through, we divide that into 3 days. We didn't make that up. It's something, I think it comes from the Kubernetes world, but I might be wrong, but it's somewhere there. And it's called day 0, day 1, day 2. Of course, we're engineers, so we start counting at 0. And day 0 is around discovery, right? So people need to find your product and go like, hey, I like this, right? I tinker around with it. I like the API. I like the clients, I should say. I think that even APIs now are a little bit outdated today, but that's another story. And so they need to like that and interact with it. Then day 1 is all about going to production. So giving people that peace of mind of like, we go to production. And day 2 is about scaling, right? So when people keep scaling. Now, that example that I just gave on our website, like if you want to build a rec application with Weaviate, it literally takes you 5 lines of code to just do the query, right? But let's say you end up with 30, right? Just for the sake of argument, 30 lines of code. What you want as a company is that you want to be able to guarantee people, if you try this out with 30 documents, just to tinker at, you're going to be using the exact same code if you have 3 billion data objects. You should not change a single line of code to get there. Now, that is very hard and complex to do for everybody. It's also for us. And that is something that we're getting better at. So we had for example, recently we had a customer incident, and we were like, what's happening? Turned out that they sent like, so you can set filters when you do vector search, and they were setting like 2,000 filters. We just hadn't seen that before. And then that went wrong, right? So then you go, oh, well, sorry. And then you try to fix that, right? So what I just said, how easy that sounds, that's how difficult it is to do. It's like when you see like a great musician, right? So they play and you go like, how can they do this? But it was like years and years and years of practice, or like somebody in sports, that kind of stuff. And that is not different from building these types of technologies.
It seems like you're quite a fan of open source. Now coming a little bit more into the model world, like how do you believe can open source models win versus closed source models? And I mean, we've now seen OpenAI going back to open sourcing some models, but they're being way worse than the state of the art models. So they're kind of like now back at it, but like not with the frontier stuff, right? And Mistral, which is like the European AI lab that is also doing open source stuff, is also not at the cutting edge. So how can open source win in the research lab world?
So I think it's very important. So we need to take off like our engineering hat when we talk about this, and we need to put on like our software business hat, because those are two very different things. So I'm putting on that latter hat. I think that OpenAI is doing the right thing, because let's go back to my previous answer to your previous question 2 questions ago. AI models are stateless, and we might remember, right? So we know that if we want to monetize them, we need to somehow make them stateful. So what you saw with the last, and we already saw it before that, but with the last GPT-5 release, that's not one model. That's just a whole orchestration that is remembering stuff. That is, and so on and so forth. State, right? That's how they make money, by keeping efficient state. And now they double down on that by starting to give away stateless stuff. You know how smart that is? It's like because you just mentioned Mistral, but there's like a slew of other companies that are competing on the model basis with OpenAI, and then just bypassing them to starting to give this away for open source. Let's not forget. I think, but I might be wrong. That I think Google was the first to do that with their not the old models, but the more modern models. Super smart, because now you start to monetize over stateful stuff, and you start to give away everything that's stateless. I think that's a very smart thing to do. So that makes a ton of sense to me. And let's not forget is that what we now call a model sometimes is also an orchestration of different models.
So who would you bet on in the LLM race? Like, and how do you see it playing out? Like, do you think there's this, and this would also include my second question, like, do you believe in something like this AGI moment of like what could this be? And because it seems like Mark Zuckerberg is somehow believing that there's like a big carrot at the end of the stick that he's chasing with like $100 million paychecks.
Yeah. So the you might if I take the AGI question separately, because that's a very complex thing. But the so do some of you remember that a couple years ago there was like this leaked memo from Google that said like OpenAI has no moat, neither do I. Do we? Do you? Yeah, I see. Yes. Do you remember that? This person was right. It's like the models are just that because it comes right out the research. So they're now, you see that they're now starting to become, it starts to even out, right? So there's no moat there anymore. So if there's remember what I said earlier, if you do something that's faster, that's only a reason, I think, to create a lot of value. Then it needs to be like significantly faster. So for example, with the quality of the models, it needs to hit it completely out of the park for people to really just pay for inference on the model. And that is changing. So I think that we're just gonna see more open source there. I really think that that's gonna happen, and more orchestration, how people are monetizing. So that is what I think will happen, and we will see. We now do not live in a, and I stole this sentence from one of my favorite chefs, but we don't live in a time of invention now, but in a time of refinement. So we're going to see more CPU inference. We're going to see more smaller models and that kind of stuff with similar qualities and trade-offs, because you already see that. So refinement. And new use cases will come out of that, but that will probably mostly be happening in the open source domain, because Google is doing it, OpenAI is doing it. I expect we see that, we're going to see that more.
And what about AGI?
Yeah. So, well, we have a couple of problems, right, with AGI. So it's like, if you just talk about language, right? What is okay, let me ask you, what is the coolest, most impressive, most resource constrained, but still high quality language acquisition algorithm that you've ever seen?
That were too many filters for me.
Okay,
Like,
so the
algorithm
the cheapest, most impressive, most resource constrained, most efficient language acquisition algorithm ever.
I don't know.
You all have seen it. Anybody wants to take a guess? A child. So the way that humans learn language is with almost no power. So the electricity is needed, almost no power. It's like it's constrained in, what is it? 200 terabytes up here. We know it's multimodal. So we know that if you take away senses from a child, that it has a harder time to acquire language. We also know that humans are perfectly well at high quality language without writing. Think about like the famous Greeks. I think Plato, he didn't write, he spoke. No, sorry, Socrates, Plato. But so if we want to look for AGI, we need to become very much closer, and I have no clue how to do it because I'm not a researcher, but to how that's similar to how humans acquire language, because what we're now doing, we have models that mimic human language, but not that acquire it, and that's a problem, because the problem is that it's called the knowledge manifold, right? So you have, if you take all these words and you put them on a plane, so these dimensions in vector space, they like, we compress them. And so, for example, the OPI models are 1536 dimensions, but they come from bigger. But let's just try to imagine that into a two-dimensional plane where we put all their information on. We can only put the information on the plane that was in the data that we trained it on. But that doesn't go for human. So we can give a human information and they can come up with new stuff. And that's still an unsolved problem. So that's also why when the whole AGI discussion is happening, we're like, yeah, whatever, right? So it's like, as long as we can't acquire information in a way that probably, maybe there are other ways, but that the human does in the form of a child, that can then also come up with new ideas that are bigger than the manifold that it has in its head, then we can start talking about AGI.
So you believe in a post-transformer architecture world for AGI?
That's the short answer, actually.
Okay, so we need a new model architecture.
Yeah, exactly. So again, that's why I was asking my question. Is like the transformer architecture is extremely resource intensive. Back to human child, the amount of power, like electricity, that a human child uses. You give it a sandwich with, like a ham and cheese sandwich and a glass of milk, and it learns a lot, right? It's like try feeding like an NVIDIA chip a glass of milk and and a sandwich. It doesn't do much. So it's like that's the first signal that there's something wrong with the architecture.
But I mean, I think the people would then say we just compute max, right? We just built like the 100 gigawatt cluster, and like just build some nuclear plants and power it, and like because we can, right? Technically, maybe do that, and there are those like trend lines of you just like max out compute, and the model performance just goes up, and
So we know that language acquisition is in children goes without reading, right? And how do we train the models? We make them read stuff and calculate distances in words. That's a second signal that we go like, maybe there's something off here. So it's like so then even if you have a magic wand and you say like, okay, we have infinite power, we can plug it directly into the sun and then whatever kind of nonsense experience, right? But then still that the core architecture is wrong to get to similar results as a human can get to. And we call it artificial intelligence, so we probably want to model it after human intelligence.
But so what would then define a model like breaking this AGI threshold? Like what does it need to do to be AGI? Like I don't know, like what is still the definition of that?
It needs to be creative. It comes up with stuff.
And who's the one to judge?
I mean, I don't
You?
think.
Yeah, I mean,
I don't think that. I don't think that's. I think that's a solved problem, right? So there's like a lot of these evaluation sets with very unique problems um, that people have come up with that they ask these models. The funny thing now is that because these things are floating around on the internet and then the models train on it, so then the model knows, blah blah. Blah. But you know, there are all these experiments, right? So if you have a cutoff date, a cutoff date when a model was trained, and a new innovation or new invention happens, you can just ask it, right? So if it can try to figure that out, and as we know right now, because of the manifold, it has trouble figuring that out, or needs to get lucky because of the randomness in there. But we just know that that's an unsolved problem, right? So I believe that the AGI sits in the creative side of it. That what makes us human, right? That we come up with new stuff.
one last question from my side before you can ask your questions. Like, if we with a potential new model architecture at some point in time reach this status, like how do you think does a post AGI world and society looks like?
Oh, so I should have given a couple more beers before I can answer that question. I don't know. I really don't know. It's like I mean, it's a good question, but I don't know, right? So it's like we're just.
Because if the AGI can be creative, then I mean now with the LLMs you would say, okay, then the humans are just like the LLMs do all the work if they reach this like LLM kind of AGI status. But like if they're the more creative ones, like what is then left for us? I mean, what do we even do?
Yeah, so I think so. I don't think that the level of creativity is very much is important, right? So it's like it just it's like, well, just to stick with children. If you see children make a drawing, it's often like super ugly, right? But it's like you go like, hey, great job, right? Because it's like nice. It's like you're creative and you're having fun. And I think that the goal in life is have fun and just have a meaningful, fun life. So that doesn't have to be better in from a creative perspective or worse. It's just doing that together. It's the same thing what we're doing right now, right? So we're sitting here with people, right? So it's like all the technology we create is to help each other communicate with each other, come up with ideas with each other. So I don't think that's going to change. It's going to just be it just constrained within human interactions, right?
Okay, thanks a lot. That was the interview part of things. Now we're gonna have, I don't know, 20 more. It depends on your number of questions, but at some point we're gonna cut it off. Q&A with you. So do you have a mic back there still? Or do we? Maybe you can give around the mic and you just raise your hand if you have a question so that we can start here.
Start here in front. Yeah. First of all, thank you, Bob, for great insights, and Bela and Tech Europe team for this organizing this event. My question is, like right now, large tech companies like OpenAI, Google often release features that resemble standalone products from small companies. In such a landscape, how should builders like us think about what to build such that it is valuable and sustainable, you know, such that no one comes and uh, builds a feature and then it's gone? What do you think?
Yeah, so I'm afraid that that's impossible. So if you create something of value, somebody else is going to try to do it too. So, but the risk in all this is that you just get a little bit paralyzed. And you go, oh my God, so many things are happening. I'm just not going to build anything. And that's always the wrong decision. So you build, and then how do you call that? You iterate, you improve, you find people around you that help you build, and those kind of things. But this is the time to build, right? So make stuff. And what is the thing that works very well is like huge ambition. So if you build something small and simple, you go like, oh, I do something small and simple, right? Because all these big ones. I think actually the small and simple things have a bigger chance of getting eaten up than the super ambitious ideas, right? If this really this moonshot idea, but let's build it, right? Then just go, just do it, just start building it.
Is there a mental framework or something to decide which ideas to build upon? Because like if you think about idea and you try to build, and then you sometimes waste a lot of time on this idea and resources, and sometimes you think maybe it's not possible. So
how many ideas do you have? You give me a number. Give me a number. How many ideas do you have?
I come up with ideas every now and then. I can't give a number, but
Give me a number. Just what do you think? Roughly a number.
yeah, 10, 15.
10. Okay.
Yeah.
So if you had to think, you don't have to say what it is. But if you have of all those 10, you think, well, if I could make that one work, oh my God, that would be amazing. Can you think of one? Like, if that one would work, woo.
Yeah.
That's the one. That's the mental model.
Okay.
Yeah.
Hi, Bob. I really like the comparison you made between how LLMs currently learn and how children learn. I want to take that question one step further. It may be a bit vague, but one difference is not only what we call sort of like the software part, the algorithm part of it. There's also a hardware difference, right? Like the brain is very different material than silicon we use right now. Do you think maybe that's also where the next sort of level of AGI can be achieved, if we focus much more on the hardware than the software part of it?
Are you Dutch?
Yeah.
I thought so. Yeah. So I like this guy already. No, no, but I'm super interested in this stuff, right? So it's there's this mental, sorry, not this thought experiment from Hume that I believe it's called tabula rasa, but I could be mixing it up with something else. So there's an experiment that we cannot do, and that's the following. So we have a couple of senses, and that's how we learn about the world and how we then create language and articulate it. We do know that if we take, for example, if a child is born blind, for example, we do know that language acquisition takes more time, right? It's beautiful. You can read about it, see it on YouTube, how people are helping these children to understand language. Sometimes children are born without sight and without hearing. So then, touch is being used to acquire language. And the experiment that we cannot do is take away all senses of a child. But the thought experiment is, can you acquire language without any senses? We don't know the answer, right? So very smart people think about that, right? So for example, those were the ideas from Noam Chomsky, right? That you're born with innate universal grammar, right? Those kind of ideas you had. So I think when we learn more from biologists and philosophers and all those kind of great people who understand how we as humans acquire language, the things we know is that the more senses we have, the faster we do it. So we know that if we still call these things models, I think we will, that these models somehow need to have multi-sensory input, somehow. And then we need to figure out if that innate talent is there to acquire language. And if we figure that out, we can write it in software. Then we can write it in software. But we just don't know. We do not know how children learn language. And that is way above my pay grade to figure that out or get an answer to that. And there are very smart people in the world working on that. But it's the models now mimic language based on reading, and you can be a very highly intelligent individual in the world without being able to read or write a single word, right? So we know that reading is not the point of entrance. It's interacting with the world. And if you like this stuff, it's super cool to dive into this. There's a lot of content online, a lot of videos online about all these different hypotheses that exist of like how we acquire language. But the long and short of it is like we don't know. But to the second part of your question, I don't know if the biological nature of our bodies plays a role in it, but we do know that we somehow need to be able to interact with the world, to see it, smell it, touch it, hear it, to understand how we acquire language. And if we figure that out, then we can put that into software and into models as well.
I have more questions, but maybe I'll just give it on.
Thank you. We're next. Hi, thanks for the chat. I had a question as more better architectures than RAG are starting to emerge, ones that involve a bit more graphs and so on. Does Weaviate have a plan on going a little bit more in the direction of something in between Neo4j and a vector database, something in that area? Are there plans for such a thing or no?
So there's actually this is funny. So it's a great question. So the funny thing is that you asked about use cases. I thought actually that the first use case was knowledge graphs for vector embeddings, and I have proof for that because if you look online, if you on YouTube, you look for a Google Stack Chat, and then just Weaviate, you'll see an interview with me from 5 years ago or 6 years ago, where I literally talk about, I think these embeddings can be used for knowledge graphs. So it's very funny. I think, and I don't want to twist your question too much, but if I may slightly adjust it,
Sure.
I actually think that we can bypass the whole knowledge graph thing. But one of the problems that we have right now is that, so if you look at what an LLM does, right? So the words get tokenized. The tokens represent an embedding. You get an array of embeddings, and that's being used to predict it, and so on and so forth. So what we now do from, for example, Weaviate's perspective, but cannot be another one, is very primitive, right? We don't make efficient use of how these embeddings are being generated. So to answer your question, I hope that we will see a future, and it depends on also, we have a research team, what they come up with and that kind of stuff, that we get closer under the hood of the models. And a funny story, so the name Weaviate comes actually from weaving the models and the database together. And the actual RAG paper talks about that too. So, and for those that want to play, try it out and play around with it, if you just take the Hugging Face Transformers library, you can see it. You can just go through it and you can see how it takes these steps. And so getting closer to that, I think solves the problem. And I think that the knowledge graph is going to cease to exist.
Thank you.
Oh, sorry. Do you mind if I add something to the previous answer before you go? So, because that for the two last questions, there's a super interesting correlation, because the concept of the knowledge graph comes from the fact that we have an ontology in language, which comes from language philosophy, and that is exactly one of the directions that the philosophers now are thinking like, well, that's actually not how we acquire language. So the path that we went down getting to the knowledge graphs is probably not the right one, because it's not how we humans acquire language based on ontologies. So that was just a thing to, so if we really want to think first principles and really want to be unique and original, then we have to go back to first principles and learn. So there was this movie recently where these aliens arrive, and then they try to, this woman is writing like these characters and she tries to communicate. What's the name of that movie? Arrival, thank you. So arrival, what you see there is the one of these hypotheses, the Safier-Whorf concept. That's about language acquisition. That's what she does in the movie. That's where the concept of ontologies and knowledge graphs also stem from. And we know that that's not how people learn language. So that's why I'm not too bullish on that concept. Sorry, this is very nerdy, but I like this stuff. So it's a great question. Yeah, yeah, probably also to trees, right? So, no, but seriously, I mean, trees communicate with each other, right? So if a giraffe starts to eat on a beautiful book, it's called the Wood Wide Web. Is the book called? It's beautiful how trees communicate. It's very primitive, it's very slow, but it's similar synapses than we have in our brains. It's super interesting.
I have a more of a technical side of question, something.
Oh, thank you.
Yeah. So basically, I built something like a job search engine, basically to kind of make job hunting easier, and I was using it myself. But I've been curious on something because I was thinking around using vector DBs to do basically job description and user profile scoring. The thing is, I didn't really implement that. I just did quite exhaustive prompt engineering and using like extract stuff and just push it out to LLMs and get detailed scoring. I've been like wondering, because we know prompt and LLM usage is very expensive, both on the chip and with the money. So like, I'm curious, kind of vector database help me go beyond raw similarity retrieval and get closer to something like a multi-dimensional scoring, which a prompt can help you with, because I'm using, let's say, 10 factors of a profile, and then you can score multiple things, right? Multiple layers, skills, or your title matches, your certifications, everything, and kind of gives you a nice score based on an equation. Or is it best approach to kind of narrow it down with vector DBs to kind of just do retrieval and then add LLMs to do more deep evaluation on it?
This is a really good question, and it's like it's a serious challenge that more people have, right? So the if you don't mind me, just for some people, because you went quite deep, so for some people they might go, what is that, what is this? So that, of course, with the prompt engineering, the problem is, like, if you feed information in it, how do you make sure it's the right information? So what we do know, the lesser information works better. So that means that we need to have an external storage mechanism to store this stuff. Now, that could be, for example, a vector database like Weaviate. But then the question becomes, how do we get it out? Because you said job search, right?
Yeah, basically, I'm just scraping everything off
Yes.
wherever I can.
There you go.
Yeah, push
So-
it in Postgres. I have them. I have users' information.
Yes.
Now it's about evaluating if they are a match amongst thousands of jobs.
Exactly. So that is like that's a huge problem, right? Because then the thing is, like, somebody might have a very specific question. Again, in the LLM, it's like more semantic in nature what they're asking for. So I could imagine that in your platform, it's like, yeah, we're looking for a software engineer that's working for 5 years in this stuff and who likes to go kite surfing because that's what we do with the team, right? So those kind of questions. So now you need to segment it in some way, shape, or form to retrieve the right candidates, right? And then put that into the model. So a couple of things there. So this is a great, also based on your question, this is going to be difficult in a tabular format because now you need to figure out what to retrieve from it and what not. The second thing that's going to be difficult is if you do that with one embedding, because you embed the whole thing and it contains everything. So what you now see happening a lot is like these multiple embeddings for different things, right? So and of course for use case, I don't know exactly how to slice and dice it, but as you can say, well, we're going to have the same profile, but this one profile is going to be represented with, I don't know, 25 embeddings. And then you can do 25 requests and then sort based on that. And those kind of things seem to work very well. One thing that we've released in Weaviate, just a little pitch, is something we call the query agent. And what the query agent does is an agent that sits in between your data and your the client. And then if you ask those kind of questions, it looks at the structure of your data, it looks at the embeddings that you have, and it formulates the query for you. So, and that also is something that works very well. So we see a lot of those types of use cases that you have, that people use, for example, our query agent, to have not you as a developer, but the agent determine what the right query is to query the database. So those kind of things we see to solve those kind of problems, but that problem all stems from the fact that we're now starting to go to more natural language querying rather than let's call it keyword-based querying. So it's what you have is a very common challenge, and so for example, our query agent tries to help solve that problem. Does that answer your question?
Yeah, yeah, kind of. So for now, would you say it's much better to kind of narrow down with RAGs vectors just to get like a content source and not push everything onto LLMs, and kind of combine them together would be a better choice for now?
Yes.
Because right now it takes me like for 1,000 jobs, takes me maybe, I don't know, less than a minute because I paralyze so much.
Yeah.
But I don't know. I've tried RAGs and it's really important, I think, to configure and, as you said, use the right embeddings. And it also gives you, I don't know, the documents that are retrieved may or may not be very good. It needs a lot of configuration.
Yeah, so but what's happening now with the agents is that it can do multiple round trips, right? I wasn't looking for that. But that's not you doing that as developer, but it's the agent doing that. So so then it writes different queries, does the round trips based on semantic searches in your database, and then brings them back to you. So you have like multiple round trips. That's the power of the agent, right? So the power of the agent, it sits in the fact that it's not a one-way street. So traditional RAG is a one-way street, but the agents can loop
Until they have found the right filters.
Yes. And you can just and if I not to make it a product pitch, but just because we have such a feature in Weaviate, you can even tell it how long you want it to search.
Yeah.
Like if you can't find it within this number of cycles, then just stop. But but that can help you as developer to find that data if you do not know what the structure is of the person asking the question.
And it usually is it faster, like pretty much faster than, would you say, an API call to
No.
LLMs? Or
no, because it needs to do the round trips, and that takes time. Yeah.
And in terms of accuracy, what would be your?
That really depends on your use case.
Yeah.
So the only thing you have to try it. Yeah. But I can guarantee you it's very cool. It's nice to see it right.
Try it out.
Yeah, you should try it out. Yeah.
Yeah. LLMs cost a lot.
Yeah, that's true.
Okay. Thank you very much.
One more question, yeah.
Hi, Bob. Thanks for your introduction of Weaviate. It's really interesting to know that something happened before LLMs. That's interesting to know. So I've been facing another problem. I also was initially trying to use RAG. Then we realized that in the context, we were able to solve the issue. The issue was I was working with the French and English documents. So that is when, they are not semantically going to match when you're in the vector space. So in that situations, do we need to translate all the languages to English, or is that the only way, right, to solve this issue? And how do we evaluate, for example, is there a better, we use LangFuse for observability and everything, but still, what is a better way to evaluate RAG systems as a whole? Like when you take the complete system, when you include a database, what is the solution in this?
Yes, I think the translation thing is, I think, a solved thing just with multilingual models.
Okay.
So you should be able to, if you store 10 documents in French but you query in, I don't know, German, then you should be able to retrieve the right document. So that should be a solved problem. And the second thing for the evaluation is it's super interesting, right? Because it's very hard to build a test pipeline based on what you're trying to retrieve if you have semantically different questions. So I think the thing that I've seen that works well is actually user feedback, right? So that's why we've seen so many of these AI-powered solutions, was this the right answer? And that's how you can do evals, right? So that
thumbs up and
yeah. And then with down, okay, there's something wrong in the structure, and with up, you go, oh, it's fine, it's good. Yeah.
for the embedding models, like, is there any recommendation? Like, for example, what is really shocking for me is Anthropic, one of the best solution for coding. They don't have their own embedding models. So, what is there anything special? Like, is there like, do you recommend any particular model that works well with a particular database, or it like, for example, I can use an OpenAI embedding model or something like that.
Yeah, I was also surprised about that they didn't release they did this whole
Voyager.
yeah
So,
Voyage, yeah. So what I would do is I would look at like efficiency of how dense the information is stored. So keep in mind that if you, for example, an OpenAI embedding is 1536 dimensions. So if you do like a prototype with 1,000 documents, you're not going to notice anything. Well, if you have 1 billion, right, you're going to notice it because your footprint is going to be double if you have like 768. And even these smaller models, they tend to do very well. So one of the things, and that is an eval you can write. So you can say, okay, I have a couple of documents. I want the order of the documents returned in this order. So ID. So when I have this query, I should see ID as 4, 5, 6, for example. And then you just try to find the model with the least amount of embeddings that returns the right order for you. So it becomes more about being efficient with it. But a lot of the models now are actually pretty good, the embedding models.